Good evening, Robert Scribbler. It is October 8th, 2018. Thank you for joining me for another climate change and clean energy video blog. Now, for this segment, I am going to dig a little bit deeper into how IPCC envisions achieving a range of about 1.5 degrees Celsius warming or less, or limiting human-forced climate change to less dangerous levels, although in reference to the previous couple of video blogs that I posted, 1.5 degrees Celsius warming still produces a number of harmful impacts. Although these impacts are likely to be far, far more manageable and survivable than warming in the range of 2 degrees Celsius or higher over the course of this century. So just looking at this graphic, and this is a measure of global carbon dioxide emissions, net global carbon dioxide emissions. And the reason why the word net is used is because IPCC envisions the deployment of negative carbon emissions, carbon dioxide emissions technology and processes, including various different atmospheric carbon capture methods, but also just a number of changes to land management to include soil carbon sequestration, afforestation, and other sustainable land management practices. So just looking at this graph, though, I'd just like to point out that in order to achieve the 1.5 degrees Celsius pathway, global carbon emissions need to fall rapidly through the 2020s and hit a net zero and net negative level in the range of about 2050. And the biggest drop-off occurs in the decade of the 2020s and into the early 2030s along the most achievable pathways, with a kind of an overshoot pathway running through the early to mid 2030s with very rapid carbon reductions thereafter, following a very steep slope, which is less achievable. The earlier pathways are always more achievable. So just with regards to these pathways, I want to talk about what has to happen. And the first thing that has to happen is that carbon dioxide emissions have to be reduced very rapidly. So for IPCC, it states that in model pathways with no or limited overshoot of 1.5 degrees Celsius, global net anthropogenic CO2 emissions, and this is basically fossil fuel burning based emissions, decline by about 45% from 2010 levels by 2030, reaching net zero by around 2050. And for limiting global warming below 2 degrees Celsius, carbon dioxide emissions need to decline by about 20% by 2030 in most model pathways. It's also worth noting that non-carbon dioxide emissions in pathways that limit global warming to 1.5 degrees Celsius show deep reductions that are similar to those in pathways to limiting warming to 2 degrees Celsius. So the primary issue with limiting warming to 1.5 degrees Celsius is cutting carbon dioxide emissions very rapidly by about 45% by 2030 and continuing to cut to net zero by 2050 with an additional reduction in non-carbon dioxide emissions, but that also have a heat trapping impact. And here in this graph, we see the projected reduction in human-based methane emissions, as well as the reduction in black carbon emissions, and the projected reduction in nitrous oxide emissions to hit a 1.5 degrees Celsius pathway. Now, the second aspect that IPCC indicates is that all pathways that limit global warming to 1.5 degrees Celsius with limited or no overshoot project that the use of carbon dioxide removal on the order of 100 to 1,000 billion tons of carbon dioxide occur over the 21st century. Now, I'd just like to state that it's far easier to prevent carbon emissions than it is to remove carbon dioxide from the atmosphere. So this carbon dioxide removal projection that IPCC provides is more of a challenge. Now, IPCC continues to note that carbon dioxide removal will be used to compensate for any residual emissions and in most cases achieve net negative emissions to return global warming to 1.5 degrees Celsius following a peak. Carbon dioxide removal deployment of several hundreds of gigatons of CO2 is subject to multiple feasibility and sustainability constraints. So there are limiters to those feasibilities, meaning that there are challenges to deployment and there might be competition, say, for certain types of land for certain uses in the event of large-scale carbon dioxide removal. Significant near-term emissions reductions and measures to lower energy and land demand can limit carbon dioxide removal deployment to a few hundred gigatons of CO2 without reliance on bioenergy carbon capture and storage. Now, it's worth noting that IPCC identifies a number of technologies and practices that can be used for carbon dioxide removal, stating that existing and potential carbon dioxide removal measures include afforestation or adding more forests, and reforestation, reforesting lands that had been taken up by agriculture. And if you use like adaptation methods such as indoor vertical farming, you can reforest some agricultural lands and have carbon dioxide removal through that process. Land restoration and soil carbon sequestration, biofuel or bioenergy carbon dioxide capture and storage, direct air capture and storage, enhanced weathering, and ocean alkalinization. These differ widely in terms of maturity, potentials, costs, risks, benefits, and trade-offs. To date, only a few published pathways include carbon dioxide removal measures other than afforestation and bioenergy carbon capture and storage. So it's worth noting that this carbon dioxide removal segment is a new and emerging technology, and at present, the critical low-hanging fruit comes from rapidly reducing carbon dioxide emissions, which IPCC in its scenario identifies as a primary goal for the next decade. So I'd just like to say also that this pathway is very challenging and one that would require innovations and activity on a human scale that we haven't yet seen, but that according to the scientists at IPCC is achievable. So a pathway for preventing very harmful warming, one that we need to take and that we need to try to take, and that scientists identify as a possible route forward, one that we shouldn't discount, one that we should pursue. Thank you for joining me, and I'll be chatting with you soon.